The Meiko 3 bridges connect the east and west sides of the port of Nagoya. The Meiko West Bridge, Central Bridge, and East Bridge are cable-stayed bridges and have earned global recognition for their size and construction. Nippon Steel has taken part in a number of bridge construction projects in Japan and abroad. The company completed construction of the Meiko East Bridge in 1997. The Meiko East Bridge is a part of the Ise-Bay Highway, which will connect the No. 2 Tomei Highway with the No. 2 Meishin Highway in the future. The Meiko East Bridge is a 3-span continuous cable-stayed bridge with an orthotropic deck and steel girders. It measures 700 meters in length, with a central span of 410 meters and 2 side spans of 145 meters each. The gross weight of steel used in the East Bridge is approximately 22,000 tons, including main girders, towers, and cables. We now present a description of the construction process of the central span enclosure of the main girders. The first step in construction is erection of the main girder. Each block is lifted straight up to the erection point from the sea below. The blocks of the main girder weigh approximately 300 tons each. The girder blocks are assembled at the factory and are delivered by a 3,000-ton class deck barge to the site in accordance with the construction schedule. The deck barge is moored at a designated spot under the erection point. Then, the girders are lifted up to the erection level via a traveler crane. The center of gravity is carefully calculated to determine the best balance, and the girders are prudently lifted up. The main girders, which are now at the designated level, are placed closely together, and their bottom flanges and webs are spliced using high-tension bolts. The deck surface is welded using a submerged automatic arc welder. The next step is cable installation. Socket sections are drawn from the cable reels by a hydraulic crane and anchored to the socket lorry. Normally, in Japan, prefabricated cable is used in cable-stayed bridges in order to shorten construction time and to ensure strength against fatigue. Clamps are then fixed to the cables at the tower side. First, the sockets and cables are hauled up by a tower top crane. Then, they are led into the tower. The insertion angle is finally adjusted by using lever blocks and chain blocks. This adjustment is accomplished by careful coordination between workers on the tower top crane, on scaffolding put up outside of the tower, and in the tower itself. The tower's anchor blocks are set after the designated amount and length of sockets and cables are led through, and anchorage of the tower sockets is completed. The next process is the leading in of cables into the girder. The sockets of the opposite ends of the cable are pulled to the designated point in the girder. Tension rods and tension wires for leading in are also fixed to the sockets. The sockets are first let in by the tension wires and then by tension rods. As the last step in leading in the sockets, a number of thin steel plates are inserted for adjustment. Installation of cable is completed by setting the cable socket in the girder. In the monitoring room located on the tower foundation, cable tensile force is adjusted at night. This adjustment work is conducted at night because the temperature is more stable. It reduces tolerance between the designated and actual figures after erection, especially of cable tensile force and position of the main girders and towers. Optimum cable tensile force is calculated, and then the cable length is adjusted using thin steel plates. Repeating the same procedures as before, east main girders were installed block by block from the tower side to the center. Finally, it is time for the closure process. Both sides of the main girder have already been set back, and the closure block is directed toward the 300 millimeter gap between the main girders where it will be fitted. The next step is to adjust the joints of closure sections. Adjustments are aimed at securing the proper position of the cross-section to the bridge's cross-axis and to the vertical axis. This is in preparation for introducing closure moment. The main girders are connected at night when the closure moment is lowest. Girder closure is conducted by reconciling bending moment with couple of force. Center hole jacks and tension rods are installed for this process. Moment is added by pulling the bottom flanges. 6 300-ton class jacks work at the same time to pull the flanges. After pulling, high tension bolts are fastened in the splice joints. The east and west main girders are connected at last. The Mako East Bridge, East Main Girder Erection. Nippon Steel completed this monumental bridge using state-of-the-art technology. The company has been involved in a number of bridge construction projects in Japan and overseas, including long and large-scale bridges such as the Rainbow Bridge. Also, we have recently developed color cables that are in harmony with the environment and scenery. Nippon Steel, spanning the gap between today and the coming century.